Hello, how are you doing? You're all very welcome here to our little webinar on further education engineering at Southwest College. My name is Brian McElduff. I'm the Deputy Head of School for Engineering, and I'm based in the Noma campus. I'm joined today by Neil Little, who's one of the lecturers and coordinators in Dungannon, and John McGovern, who's also a lecturer and coordinator in Dungannon, and Huey Klein, who's based in our skills centre in Enniskillen. So the purpose of the little presentation is to give you an idea about the college, an idea about what we do at in the area of engineering, to help you make your mind up with regard to what you'd like to do in September. So as we go along, you have the opportunity to ask questions by using the little icon that you see on the screen there. So if you click on that little icon, you can type in any questions, and the rest of the team will be able to answer those for you as well. Okay. Hopefully, as we go through the presentation here, we'll cover most of the information that you need to have. But certainly feel free at any point to ask any questions that you feel are relevant. So firstly, before we talk about engineering, why should you study at Southwest College? Well, it's a good college to study at regardless of what course of study you choose to do. You can see some of the pointers on the slide there. Okay, we have excellent quality of teaching and learning, and we're regularly inspected by the department and EPI, and we consistently come up with very, very high, outstanding grades in that area. Good links with local employers and industry for a wide range of courses and work placements and so on. A whole new range of people and diverse people you wouldn't otherwise meet, perhaps if you stay at school. The courses that we offer are very much linked to industry and the workplace. Okay, and think about the job that you ultimately get at the end of your studies. Work placements and project-based learning are a big element of what we do. It's not all that we do, but it's part of what we do to try and make the courses as relevant to your workplace as possible. And even more flexible timetable and time for part-time work and sports. It's not a 9 to 3 or 9 to 5, 5 days a week program. All right, so you might be in 3 or 3.5 days a week, and that leaves you other time to do different things. Okay, the college also provides quite a bit of support, so the staff are supportive. Okay, friendly staff that try and support you, and you can speak to any of the staff at any time if you have any questions or queries as you go through the year. There's a range of extracurricular activities which we'll mention later on. Depending on your course of study, there's competitions and international and UK-wide competitions you can take part in. You've accessed our innovation centres for using equipment and resources for your own interest in your own project work outside of your course of study. And we have the staff that you'll be engaging with have a great deal of industrial experience, which helps in the classroom to link the theory that we talk about in class to what you might meet in the real world. As well as that, you have more of the standard support that you expect to get. You may be entitled to EMA, and the same if you have to stay at school for full-time study. You get your PPE to wear if you're in the workshop, but there's no uniform. So it's different to school. There's no uniform. You have a whole range of progression opportunities, which again we'll talk about later on as well. What you can progress to after you do your FE in engineering, and there's international opportunities such as Erasmus placements and so on. So before we had the recent shutdown, some of our engineering students were going to go to Malta for a couple of 3 weeks placement. Unfortunately, that didn't work out, but hopefully it'll turn out as an opportunity again in the future. We have a lot of high-tech and modern facilities, and we're continually renewing our resources. So we have industry standard equipment such as robot arms and automation equipment and hydraulics equipment and so on, that you'll also see out in industry, and we have it in the college to help with our training. Okay, and given the difficult time we're in at the minute, where there's a lot of potential for online delivery, we have a lot of experience in that area. And if we still need to deliver some of the program online next year, we have the facilities and the technical resources and the experience to do that, as well as anybody. Okay, so once again at the college, there's clubs and societies. You can see a list of some of the clubs and societies you may be interested in there, soccer and various sports and so on. And we have counselling facilities as well, as you would expect, that you can make use of as you go along. So pastoral and financial support, free counselling support for those students that might need this to go along. Okay. So talking about the course itself, So the course you're hopefully interested in today is our BTEC Level 3 in Advanced Manufacturing Engineering. So for us, that's a full-time program of study. It's equivalent to doing 3 A-levels in terms of UCAS points that it may attract. So it's like doing 3 A-levels, but you're doing a range of subjects. So you're doing 17 different subjects throughout the year, which we'll mention throughout the 2 years. And we'll mention what they are later on, okay? Assessment, unlike A-levels, there's no external examinations, okay? So assessment, as you can see, is by assignments and class tests, practical tasks, project-based learning activities, which encompass several units coming together to do a piece of work. Timetable is typically 3.5 days a week, not always that, but typically it's about that, okay? The modules, there's a broad range of modules that we cover. You're not just doing the same thing over and over again. And we do a broad range of modules, so you have maximum choice when it comes to doing further study. You know, we're not limiting you to just electrical engineering or just mechanical engineering. We do all a whole range of studies, so you can go different pathways after you finish your studies. And as was mentioned before, all of our lecturers have industrial experience, so they've worked somewhere else before they come to the college, so they can bring that experience into the class, into the teaching, and help you get a better understanding as to how the theory that you're discussing in class links to what you may do in the real world. Okay. So here's an idea of some of the subjects you might do. I'm not going to go into them in detail because you don't want to hear that level of detail, but it is an academic qualification. It's not a work-based learning qualification. So it's been mentioned that it's equivalent to A-levels, so it has academic rigor. So you do maths, you do electrical principles, mechanical principles, and those types of theoretically and science type subjects, but we also keep it practical and linked to the real world. So you do CAD, you do some welding, you can see that you do some programming robots and things like that. Okay, and fabrication processes. So that's in the workshop, using some of the lathes and the CNC equipment to do bits of project work. It's not all what we do, so it's important to be aware of the fact that you're also doing maths and science and a lot of classroom work, but where possible, we get into the workshops and we link that to a bit of practical work as well. Okay. In addition to those subjects, you also have the opportunity to do additional qualifications in, say, welding or CAD, which, although they're not part of the program, they sort of make the CV look better and make it more employable for later on. Okay, work experience is something people often ask with regard to this qualification. It's not an essential element of the program. So you can go right through the program without any work experience and you still get a really good grade at the end of it. There's no issue. But we do encourage you to get work experiences for your own benefit. You know, make the CV look a bit better. Ultimately, you'll be wanting a job somewhere. If you have some work experience, that will go in your favor. So I've already mentioned that the classes are typically 3.5 days a week. So you have a day and a half plus to go and get any part-time work. Now, if that can be linked to an engineering company, all the better. It means you're getting that work experience at the same time. Okay. If you don't have regular work experience week upon week, we are involved in the Career Ready program, and that's a formal UK-wide process where students studying at the college can link with local employers. They get a bit of mentorship, so they have a contact with somebody in that company, and they speak to them several times through the year. But the main element is at least a 4-week placement during the summer. So that company will take you on, give you some relevant engineering experience. As I said before, that will then help the CV and give you an idea of perhaps what job you'd like to do in the future. Right? Part of the Career Ready scheme involves what they call a capital experience, which is a trip typically to London to visit a big employer and to take part in other activities with other Career Ready students from different colleges in different parts of the UK. Okay, and you can check out that Career Ready website to find out more information about that if you wish. Okay, here's a slide of some of our students, our Gannon students last year when they were away in December to London, and they enjoyed it. It's a long day. It all happens in the one day. They travel, spend the day there, come back late that evening. A long day, but all the students enjoy it. And every year it's becoming more and more popular. Okay, progression. So if you do your BTEC Level 3 in Advanced Manufacturing Engineering, you can progress onto various different routes. So firstly, the grade you get at the end of the program, at the end of 2 years, so it's a 2-year full-time program, you get a pass, merit, or distinction grade. So UCAS points for those grades if you choose to go on to university. You can see on the slide there, pass is 48 points, merit is 96 points, and the distinction is 144 points. So a distinction is equivalent to getting 3 A's at A level. You get the same UCAS points for that. And you can apply through UCAS and go to university. Any university you like that will accept you. Okay, so you can progress on to higher education. That may be a HNC or HND or a foundation degree at the college here, or an honours degree. You can stay at the college and do your full honours degree as well if you wish. And that could be in the areas of mechanical or electrical engineering or clean technologies or computer science or a whole range of subjects. The same as somebody doing A levels, they'll have a range of A levels they've done. They apply to UCAS at the courses that will accept those grades. You'll have the same opportunities there. Okay. If you choose not to go into higher education, you can, of course, go directly into employment. And there's a list of some of the jobs our students have had straight from the college. CAD technician, mechanical technician, quality control, those types of jobs. But there's a whole range of jobs. And we're lucky in this part of the world that there's lots and lots of engineering jobs typically. So there's good opportunities in the local area to get good employment. Okay, so hopefully that's okay. I say continue to ask questions. If I haven't maybe not mentioned something that's relevant to you, feel free to type up your question and the team will hopefully answer as we go along. I'm just going to hand you over now to my colleague Yui, who's going to talk a little bit about the project element of the course and give you an example of a couple of students that have done particularly well working through the project element of this program. Not all students do as well as this, but these are two really good students and give you an idea of what opportunities you have. Okay, so hope you found it useful up to now. I'll just pass over to you. Okay, thank you.
Hello, good afternoon. My name is Yui Klein. I'm one of the lecturers in Enniskillen, and I teach one of the modules, which is communication and projecting. The reason why I wanted to talk about projecting is because it actually kind of amalgamates all the different modules and knowledges you gain during your first and your second year. We will have there an individual kind of work laid out, but as well a lot of teamwork is involved. Next slide, please. Here you will learn as example what the project means, the project cycle, what the implementation means in order to achieve a finished product. You will learn to link your scientific or other scientific discoveries to a commercial application. So as example, if you're looking at your mobile phone, we will talk about how it comes to a finished product from the first conception of an idea. You will gain here project management skills where you learn functional requirements, quality and design effectiveness, but as well things like reliability and safety, what's most important nowadays in the development of certain products. Here you will also learn how to provide to your customer an estimation of time and costs in order to run a project. It doesn't make sense really to produce something and then you have to find out at the end that it's far too expensive for the market to accept. So you will have to learn here the skill of producing something for a cost attractive enough for the market. I had some very good students in the past. One of them just finished year 2 is Christopher. He came up in his project with the idea of gym equipment, but gym equipment made by himself in a more cost-effective way. And here you see on those pictures already some of the parts he has produced by himself. And he has established with his idea of weightlifting equipment and with some kind of fitness equipment already a business. Obviously, I will teach you guys as well kind of an entrepreneurship, how to approach a market, how you could actually find out that the market is there and wants it. Yeah, so he took that on board and approached via eBay and other web-related letouts to market his product, and he got orders straight away in from day one, so much so that today he has a massive order in from a big, huge gym company, which is based throughout the whole of Ireland, to produce for him for the next 1 year gym equipment. That means he has already more or less a monthly income alone by producing his gym equipment. In addition, he has started now, you can see those fireplaces on the bottom left, a lovely idea he has picked up on, and making it as a flat pack now in order to be able to send it when people buy it over eBay. So he learned by us not only to work with the materials, but with the machines. He has been taught in programming a laser cutter, as example, or plasma cutter, which he used in order to cut the metal, etc. And obviously the welding skills, which enabled him to produce those items. On the next slide, you see here examples from Hannah. A few years back, Hannah was in my class. She wanted to become a mechanical engineer, but very quickly we established that she had a talent for engineering design. And as a passionate motorcycle rider, she felt that she wanted to have a camera on her helmet. As you can see in the first example, she came up with a holder for the camera on the helmet, and we spoke it through. And what you will learn as example as well in the class is the not only the ability of the idea you have created, but as well the suitability. Yeah, so we spoke about the wind which goes around your helmet, the draft, etc. So she had to redesign everything until she came to the concept in the middle with a camera attached, which has a lens to the front and to the back in order to monitor the traffic like a black box in an aeroplane. She actually was so successful with her design, she decided to join university and did a degree now in engineering design, and sold her idea to a Japanese company who built then out of her idea the helmet. On the right hand side you can see. So you can see you would not only learn theoretical skills, you would learn as well skills, typical engineering skills, you would hopefully be able to use for your own advantage in the future, seeing how engineer works from the moment of a conceptualization of your idea to bring it to fruition and see it on the market. And with a simple, nice idea, you may be able to even make a bit of money out of it. I will hand back to Brian. If you have any questions, Brian is on now.
Thank you. Yeah, sorry, thank you again for that summary of the project work we do with some of our students, and for highlighting those two particularly good examples from students that we've had. Just to give a flavour of what opportunities are available if you do this sort of course of study. Again, I'll just remind you, if you have any questions, please don't hesitate to type them up in the little question box. But if you do think that this course of study is worthwhile for you, something you'd like to do, it's a full-time program, an academic program, gives you opportunities to go into university or go into employment, and gives you a chance to get some work experience as well in your own time. If you think it might be for you, please go to the website, go through the application process. You need to create an account and apply the process, but all the details are on the website. And we're available now for a few minutes to answer any more questions that you might have. Thank you very much for your time, and please don't hesitate to contact the college if you have any other questions, even after today. Okay, thank you very much.